Good day. For those of you who do not know us, we're the instructional staff for ECE 150, professors here in Patel and Van der Dietl, and Douglas Harder. In this topic, we're going to discuss the switch statement. So in this topic, we will describe deeper cascading conditional statements, explain how the switch statement can be used instead, and give some examples. Here, for example, we have a cascading conditional statement that checks if the error code is equal to 0, 1, 12, 13, 42, and deals with those as special cases while dealing with all other codes in general in the alternative block. Here's a conditional statement that allows you to react based on whether or not a particular character is a vowel, the letter Y, or a consonant. Here's a conditional statement that converts a character, be it from 0 to 9 or A through F, into the corresponding numeric equivalent value of that hexadecimal digit value. Here's a cascading conditional statement that could be used, for example, in parsing an arithmetic expression, dealing with numbers, or parentheses, or plus and minus, which could be either unary or binary, and multiplication, division, and modulus, all of which in C++ are binary. And then, of course, you deal with anything else in the complementary alternative statement. Now, in all of these cases that we've just seen, there is a single variable that is being repeatedly compared with either individual constants or a very small range of constants. Such sequential testing requires a little bit more time than usual, especially once we get to that final test. So C++ includes a shortcut mechanism that allows either a mathematical formula that is formulated at compile time, or a lookup table, or a binary search thereof, or a combination of these, perhaps with simpler conditional statements. All of this is wrapped up into something called a switch statement. Now, the term likely derives from older mechanical switching devices that could make connections based directly on a value. So in this example that we started with, we checked the error code against 0, 1, 12, 13, 42, and everything else was dealt with in the complementary alternative body. To implement this as a switch statement, the error code becomes the argument to the switch statement. Now we have a number of cases. Case, also like switch, is a key word. And the value following case is a possible value that the argument may take on. So in this case, the argument is some sort of integer data type, in this case int, and now if error code is equal to 0, we jump to case 0. If error code is 13, we jump to case 13 and start executing there. When we reach the break statement jumps to the bottom of the switch statement and continues executing from there. Now, if the break statement is not there, then it just continues executing the code within the switch statement until either the end of the switch statement is reached or a break statement is reached. There's also the default. The default case is for every other case that is not met in previous cases. So that's essentially the complementary alternative. Here's our second example where we reacted to a vowel, the special case of the letter Y, which may be a vowel or a consonant, and otherwise we dealt with all consonants. We could implement this as a switch statement, which would probably execute quicker. So we do a switch on the argument ch, which is of type char. So now we have case A, which appears empty, but that's okay because we will just continue executing. So we also have case E, case I, case O, and case U, and then we actually perform some sort of action. So if the character CH was any of these 5 characters, we would start executing the code that indicates a response to a vowel. When that code is finished executing, the break statement is executed and execution jumps to the end of the switch statement. For Y, there's code to deal with that letter, and then once again we execute a break which jumps to the end of the switch statement. If it is not one of the 5 or 6 cases we've already looked at, the default statement or default case is executed, whatever it happens to do to all other consonants, assuming of course that it isn't a symbol or something else. So in converting a hexadecimal character into its integer value equivalent, here is the following switch statement. So we are switching on a character that is assumed to be either a digit or a letter from A to F. And if the letter is anything from 0 to 9, then we just return the character value minus the character value of 0. So that will return a value between 0 and 9. Then if we get anything that's lowercase a to F, we return that value subtracted from A, subtracting A and adding 10. That will give us a value between 10 and 15. And we do the same for capital letters. Now note, importantly here, because we are returning, we don't have to break, because the return statement will exit from the switch statement. Of course, if we get to the default, we're just going to throw an invalid argument exception. Now, something that was pleasing about the previous switch statement is that it was easy to write, and it's easy to look at the code and immediately see that it is working correctly. However, it may not be the most efficient means of doing or performing an operation. In this case, here's a much faster way of converting a hexadecimal character to an integer character. What I have done is, observing that the character 0 has an ASCII value of 48, I have discarded the first 48 ASCII characters. Then, in rows of 16 characters, I have replaced each character with its corresponding hexadecimal value if it represents a hexadecimal character. So that includes 0 through 9, capital A through capital F, and little a through little f. Then all I do is, for whatever character you give me, I subtract off the ASCII value of 0 and look up the corresponding entry in this table. So, for example, the ASCII value of 0 is 48. 48 minus 48 is equal to 0. So this would look up the first index 0 of the array. Next, capital A. Capital A appears as, or has, an ASCII value of 65. So 65 minus 48 is 17. And if we look up index 17 in this array, we get the value 10. Finally, the ASCII value of the character little f is 102. 102 minus 48 is 54. So we would look up the 54th index of this array, and that would return the value 15, which is the ASCII value for, which is the hexadecimal value for little f as well. Now, one thing to point out, I have a very complex assertion here, and so you may say that this is significantly slowing down the code. However, always remember, all assertions can be turned off when you are compiling for production code as opposed to compiling for development. So this assertion will be tested during development, but when you deliver the product to the end user, this particular statement will not be tested nor even included in the compiled code. So this will simply return back character minus the ASCII value of 0, or 48. And here is the example of dealing with code that could be used for parsing an arithmetic expression. So once again, if it's a new digit, we deal with it as if it was a number. We have two cases for opening and closing parentheses, and the cases for plus and minus are the same. Similarly, the case for multiplication, division, and modulus will be the same. Finally, there's a default that has us deal with anything else, for example, identifiers. Now, the argument of a switch statement must be of either integer, character, or Boolean type. It cannot be of type float, double, a pointer, or any instance of any class. However, it can be an enumerated type. So for example, here we have an enumeration of weekdays, and because these are all treated internally as if they were integer values from 0 to 6, essentially we're just doing a switch on an integer. Now, in this case, here's a second example of using a switch statement to, for example, calculate the length of a particular month. Now, once a student learns about a switch statement, they tend to want to use it more often than not. However, in this case, it may simply be easier to use an array. So here we have an array of 12 months that stores the number of days. And if the current month is February, we have to calculate. However, if the current month is not February, we just look up the length of the month in the table above. Now, the most significant source of error with switch statements is when novice programmers forget to include a break statement at the end of each case if their intention is that that code is intended to be executed exclusively for that case. So in this humorous example, if you were to have weekday assigned the Tuesday value, well, then it would write today is Tuesday, today is Wednesday, today is Thursday, Freya's day, Saturn's day, and the sun's day. And finally, as a bonus, the assertion will cause an error in execution as it too will be executed. So of course, the correct thing to do to fix this problem is to include a break statement at the end of each case. Now, one of the most underused features of switch statements, and it doesn't It's not really that useful all that often, but in a few cases it's actually quite nice. For example, here, we are once again doing a switch on an error code. However, for all error codes, we do want to log the error. However, for some errors, such as cases 1, 73, 97, 40, 54, 253, and 255, these are considered to be serious errors and require the user to be alerted about the problem. However, cases 5, 16, and 154 are critical errors, and this also requires the filing of a report, perhaps back to the developers. So as you can see, there are no break statements. So if the error code was 5, 16, or 154, then the report would be sent, the user would be alerted, and the error would be logged. If it was any error that in the second batch of cases, a report would not be sent, but the user would still be alerted and the error would be logged. For all other cases, it would simply occur that the error would be logged. So, following this lesson, you now understand how and when to use a switch statement, and you are aware of the potential benefits. Here are the references, the colophon, and a disclaimer. Cheers!